Hello everyone, today we're going to study about nomenclature. Nomenclature is a naming system. We are trying to name organic compounds versus inorganic compound. How do we name them? So I'd like to start with first inorganic compounds. How we name inorganic compounds. So first of all, for inorganic compounds, most of them are composed from metals and non-metals like ionic compounds. There is certain nomenclature systems that we need to follow. I would like to start with anions. So you know, anions are negative ions. Anions can be divided into as a monoatomic anions, and we also have a polyatomic anions. And what are the monoatomic anions? Say for example, O-2, S-2, N-2. These are monoatomic anions. Chloride -1, bromide -1. Okay, these are called monoatomic anions. We have a polyatomic anions, especially the standard one are SO4 2-, which is a sulfate ion. You can see sulfate ion here. This one is sulfate ion. NO3-1 here. NO3-1 is called a nitrate ion. You have a nitrate ion here, a sulfate ion here. A phosphate ion. These are called a polyatomic ions. The reason why we call polyatomic because they are composed more than one atoms. So now here is the thing. Most of the polyatomic ions, the standard one, are ended with ATE. This is one of the things that we need to know, the difference between ATE, ITE, and also IDE. For anions, we use this ATE, ITE, and IDE. So like I say, ATE is a common polyatomic ions. It can be chlorate, ClO3-, sulfate, SO4 2-, nitrate. These ions, the one that ends with ATE actually somehow needs to be studied. But the ITE groups, mostly the ITE groups can be generated from the ATE groups. In other words, if you reduce one oxygen, then it turns into ITE. So you'll have ClO2-1. That's going to be chloride, ITE. If you have sulfide comes from sulfate, so it's going to be SO3-2. Nitrite is going to be NO2-1. See, so the standard ion, the ones that ends with the ATE group, they are the one who needs to be studied. You can see some examples here as well. You have chloride ion, you have sulfide ion, you have nitrite ion. Now the IDE groups are the monoatomic ion. For example, you have chloride, that's the IDE group. Sulfide, S-2. Nitrite is going to be N-3. The numbers is always corresponding with the groups where the ions are located. Chlorine, for example, is in group 7, as you noticed, and the charge of chlorine must be -1. In other words, chlorine has to gain 1 electron, so its charge will be -1. And then you have sulfur, but if it is in an ion form, it turns into sulfide. It has to be ended with IDE. Sulfide, a charge is -2 because it's located in group 6 and it needs 2 more electrons. Nitrite has a charge of -3. Okay, so in naming the anions, you have to know where the ions are indexed with ATE, ITE, and IDE. And then that way it would be easier for us to name inorganic compounds. For metallic ions or cations, you really don't have to use a suffix ATE or ITE. For example, if someone wants us to say the name of this ion, a sodium ion, you just say sodium ion. But when it comes with transition metals like copper or iron, you will have to say, because transition metal forms more than one charge, we call them a polyatomic cations, so we have to use Roman numeral. So this one, for example, would be like copper, Roman numeral 2, iron. Or this one would be like iron, Roman numeral 3, ions. Okay. In some literature, you may have to use cuprous and cupric, ferrous or ferric, but we're not using, the modern chemistry doesn't use cuprous or cupric, but they prefer to use Roman numerals. It makes things easier. So if you have 2 charge, you put Roman numeral 2. If you have 3 charge, you put Roman numeral 3. That's for naming metallic ion. When you name non-metallic ions or anions, make sure that you have a monoatomic ion or a polyatomic ions. Whenever you have a monoatomic ion, you use IDE, like we have here, like chloride, sulfide, nitride. Whenever you have a polyatomic ion, you have 2 options. You need to use ATE or ITE groups. So the ATE are the standard that needs to be studied, but the ITE is always one less oxygen than the ATE groups. So then we have something called the per and hypo. So like I say, is let's take this example here. We have bromate ion. If you look at bromate ion here, bromate has a standard ending. It is bromate. Let me write this down. Bromate ion. It ends with ATE. Then you have options here. We use a prefix per. See per here. We use a prefix per if you add 1 more oxygen. Like per is always a sign of adding more. So let's say we have BrO4 minus. So everything is not changed, but you're going to use a prefix per. You say per bromate. Okay, and let's say that you lose 1 oxygen from the standard ion. It's going to be bromide ion. And if you take another oxygen out, it's going to be hypobromide, because there's a deficiency of oxygen here. Hypobromide ion. Okay, so if it's just by its own, you can say bromide. That's the difference that we need to know. Bromide ion. So like I say again, you have to be focused with the standard one, which is the one that ends with ATE. And then if you add 1 oxygen, you have to use a prefix per. If you take away 1 oxygen, then the standard one, it has to be said bromide, ITE. If you take another oxygen from bromide, you may say hypobromide, so the deficiency of oxygen. If it is single, you say bromide ion. Okay. Now, adding oxygen or taking away oxygen is not a matter of losing oxygen, but it has a very great impact on the chemical and the physical nature of the ions, in terms of solubility, in terms of oxidation reaction, in terms of acid or base. I mean, we can name so many things. So it's not just like mathematical equation. It has something to do with the chemical and the physical nature of the ions. I can give you some example. Maybe we can have iodate. Let me start with iodate. Iodate is a standard polyatomic ion ends with ATE, And if I need to have per iodate, I would add 1 oxygen. This is going to be per iodate. If I take away 1 oxygen from the iodate ion from this, and if I have IO2 minus 1, it's going to be iodides. Remember, iodides. And if I have to take away 1 less oxygen than the iodide, it becomes IO minus. It's becoming hypoiodides. Okay, and finally, if I have just I by itself, it's going to be the iodide ion. Okay, so you know, you may have especially the oxyanion, this kind of characteristics, not for all anions, but oxyanion ends with halogens. Okay, when you have oxyanions, in other words, if oxygen is reacted with any of the halogen groups, that you would have more extension. You would have the iodates, periodides, iodides, hypoiodides. If it is chlorine, you may say chlorates, perchlorates, hypochlorides, or chloride, etc., etc. And we're going to continue, and we're going to do some examples of ionic compounds and inorganic compounds actually, and we're going to name them. The purpose of this video is how we're naming inorganic compounds and organic compounds. So this might be a good example for the oxyanions related with the halogen family. You have chloride ion here. If it is by its own, like I say, it has to be ended with IDE. Now we have to focus with the common representative oxyanion, which is chlorate. Now look the picture here. If you add 1 oxygen, you ended up with perchlorate. This is going to be per, because you add 1 oxygen to the common polyatomic ion. If you take away 1 oxygen, you ended up with chlorite. If you take away another oxygen, you ended up with hypochlorite ion. This is how we name some of the common polyatomic ions. Now, again, you know, try to study ions that are ended with ATE. That's very important. The ITE and the IDE, or the per, or the hypo, comes from ATE. ATE is your standard. That's the standard one, and you can able to break down into these groups. There are also some common polyatomic ions, but they don't follow the rules. They don't have to end with ATE or ITE. For example, you may have OH minus. That's called hydroxide ion. This is a very important ion to determine whether the solution is acidic or basic. And if you have a compound that has OH ion, it is called the alkaline solution. Alkaline solution is one of the common polyatomic ion made from oxygen and hydrogen and has overall charge -1. We have a cyanide ion, Cn-1. The cyanide ion also doesn't follow the rule of ATE and ITE. It's one of the poisonous compound, but it's considered as a common polyatomic ion. So hydroxide ion and the cyanide ion is also a part of common representative ions. So like this way, once we know this, and we're going to learn how to name compounds. Say for example, if you like to name Na2SO4, so this is called sodium sulfate. You always start with a metallic compound, sodium sulfate. Oh, one thing I forgot to mention about carbonate and bicarbonate. The word bi refers to 1. Okay, so word di refers to 2. Okay, tri refers to 3. The reason why I'm saying that, say for example you have a carbonate ion, which is one of the common polyatomic ion. That's a carbonate ion. Okay, now if you add 1 hydrogen to the carbonate ion, the overall charge is going to be changed into -1 because hydrogen has a +1 charge, so it consumes the -2 charge and you're left out with a -1 charge, and this time it's called a bicarbonate ion. It's going to be a little bit more alkaline, weak alkaline or basic solution, so it has impact in naming system. Compare sodium Na2CO3 versus NaHCO3. Now Na2CO3 would have a name of sodium carbonate. Okay, sodium carbonate. And NaHCO3 is going to have sodium bicarbonate. So that's the difference. Actually, the reason why bi comes from, because it comes from one hydrogen ion. Okay. If you have PO4, which is a common polyatomic ion, so that's going to be phosphate. Phosphate. If you add one hydrogen here, it's going to be HPO4 with overall charge -2. It's going to be biphosphate. Biphosphate. Again, bi comes from hydrogen. Okay, before doing some examples, I would like to explain about how we name acids. Acids are compounds that have hydrogen ion. So if you have a compound like HCl or HNO3, H2SO4, all these are acids because they have hydrogen ions in it. So how do we name them? There is a simple logic or a simple way for that. If you have an ion indexed with ATE and the corresponding acid would have a suffix IC, so that's very important. Okay, if you have an ion indexed with ITE, the corresponding acid will have a suffix OUS. And if you have an acid indexed with IDE, if you have an ion, if you have an ion indexed with IDE, you have a prefix hydro and a suffix IC. Okay, I'm going to give you an example. Let's take phosphate. Phosphate has PO4 3-, it is phosphate. And if I would like to name phosphates, the corresponding acids that made from phosphate, obviously I'm going to add 3 hydrogen ion. The reason why I add 3 hydrogen ion is to balance with the overall charge of 3-. Phosphate has overall charge 3-, so this is going to be H3PO4. Now phosphate indexed with ATE, so the rule says I have to put for the acid, for the corresponding acid, I would say phosphoric acid. Phosphoric. You remove the ATE and you substitute ATE with IC. Okay, this is a key rule here that we need to follow. This is a key rule. I'm going to put a star here, maybe. Phosphoric acid. Now, if you have phosphite, let's say you have PO3 3-, this is phosphite, comes from phosphate. It's phosphite. And I would like to now the corresponding acid that made from phosphite is going to be H3PO3. And the name this time, as the rule says, instead of ITE, you say phosphorus acid. Phosphorus, OUS, phosphorus acid. Okay, so how that comes, because ITE always has to be dropped and then you put OUS. Now let's take a monoatomic anion. Okay, I would go with HCl. Say, for example, Cl, which is chloride ion. Chloride ion is a monoatomic ion, and the rule says if you have an acid like made from a monoatomic anion like HCl, you need to use this time, you need to use a prefix hydro and a suffix ic, which is hydrochloric acid. So if you have bromine, for example, the corresponding acid, which is HBr, and when you name it, you say hydrobromic acid. That's how we name them. If you have H2SO4, what do you think the name would be? The name again is made from the sulfate. Sulfate has the name of sulfate is ended with FATE, that's sulfate. So the corresponding acid would have a formula of H2SO4. Remember, the number of hydrogen always match the overall charge, okay? Because you have 2 minus here, you need to put 2 hydrogen here. Now the name would be sulfuric acid. And instead of sulfate, you say sulfuric acid. So now we're going to make some practice of some of the compounds. Let's say I have copper ClO4 2, and we would like to name it. I would go with KNO3. Maybe like I'm picking H2CO3, FeOH2. Okay. How about if I say NH4? Sorry, NH4. Just thinking NH4. Let's say NH4 to SO4. How about that? Mg3 PO4. Okay. Let's first. Okay, let me add one acid. Maybe. How about if I say CH3COOH? Now, this compound is made from copper and perchlorate. Remember, chlorate has ClO3 minus 1. Perchlorate would have formula of ClO4 minus 1. So if I look up the number here, it's 4. Then copper is a transition metal. I would say this is called copper 2. How do I know 2? That comes from here. This is reflecting the charge of copper. Copper 2 perchlorate. Perchlorate. Okay, we have a compound here, KNO3. That's going to be, K refers to potassium. And this is a common polyatomic ion, potassium nitrate. This is an acid because of hydrogen here. So it's carbonate. Like I say, the 8E group has to be changed into what? Into IC. If you have an acid. So instead of carbonate, you say carbonic acid. FeOH2, it's like alkaline or basic solution. Now remember, Fe is a transition metal, so you would say iron, Roman numeral 2, hydroxide. Now Roman numerals because iron is a transition metal. Now this is ammonium. I forgot to tell you that ammonium is also NH4 plus 1. It's one of the common polyatomic ion doesn't fall in the rules of ATE or ITE like hydroxide. So it's also need to be studied. Ammonium ion. So this is going to be ammonium sulfate. And you have here we have, this is 4, I'm sorry for my writing, magnesium phosphate. And this is another common polyatomic ion. It's called acetates, CH3COO minus, or sometimes as molecular formula you can say this is the same as C2H3O2 minus 1. It's acetate ion. Now here, because of hydrogen is present, so you can say acetic acid. Whenever you have ATE, ATE has to be ended with IC, so acetic acid. So the next naming system refers to organic compounds. The naming system of organic compounds is different that we have seen in the previous lecture. So first of all, what are organic compounds? Organic compounds are compounds. These are compounds contain carbon and hydrogen, mostly carbon and hydrogen, and some elements like oxygen, nitrogen, chlorine would be involved, but it's a compound mainly has carbon and hydrogen. So when we are dealing with the naming system, there is the big classifications. I'm going to for this class, we're going to focus on alkane groups, alkene groups, and an alcohol groups. I mean, it's not just, these are not the family of organic compounds. There's, in fact, there is huge number of organic compounds compared to inorganic compounds. The reason why organic compound is too many in numbers, because they share electrons. They can easily form a compound. But whereas ionic compound needs a lot of input. It's a transfer of electrons between metals and non-metals, but these are sharing of electrons. So there is a huge differences in numbers, in quantity of organic versus inorganic. So how do we name the alkane compounds? First of all, the alkane compounds are compounds, organic compounds, contains only carbon and hydrogen. They contains carbon and hydrogen. Okay, so they don't have any other foreign elements like oxygen, nitrogen, and chlorine in most cases. So now, one of the things that we need to know, the alkane groups, most of them are ended with ANE. They have a suffix ANE. Whenever you see ANE, it is a family of alkane. So I'd like to start with a simple compound of the alkane group, which is called methane. Methane, M-E-T-H-A-N-E. Then we have ethane, which is C2H6. That's called ethane. We have C3H8, which is propane. C4H10, which is butane. Notice here that every of the compounds are ended with ANE groups. We have C5H12, which is pentane. Now, I know sometimes it's very hard to remember how many hydrogen atoms are associated with each carbon atom. So what has been discovered is that there is a formula that works for the whole alkane family. So I would suggest, if you remember this formula, CnH2n plus 2, where N refers to the number of carbon atoms. It's number of carbon atoms. What does that mean? For example, if you have N, which is 6, right, and you like to know how many hydrogen atoms are associated with 6, it's going to be C6H 2 times 6 plus 2, which gives you C6H14. Now, there is a prefix that we use in a Greek letter for 6. 6 is hexane or hexa, so you just say hex, n. If you have 7 or 8, 8 is the most common number in chemistry. So how many hydrogen atoms would be associated with 8? So C8H 2 times 8 plus 2. That gives you actually C8H18. C8H18. That's going to be 8 is octet. You remember the octet rule, I believe. So the name is going to be octane. is going to be octane. Remember, this is the alkane family, and all alkane families are following the rule of CnH2n plus. That's very important to remember. Okay, the next big group is the alkene group. Unlike alkane, the alkenes are ended with a suffix ene, and the alkenes are double bonded and they are unsaturated. We call them unsaturated. In other words, they need more hydrogen compared to they can be reacted with other elements, whereas the alkane group are saturated. I don't know if I mentioned that earlier. Alkanes are saturated. In other words, saturated or unsaturated comes from the number of hydrogen atoms that each carbon holds. So carbon is a group 4 element, so it holds 4. So you have 4 hydrogen here. It's saturated. It cannot hold more than 4. Okay. So the alkene, like I said, they ended with ene. So they also have a formula of CnH2n. This is the formula that will for the all alkene family. Okay, remember alkane has CnH2n plus 2. That's for alkane group. Okay, so what we can see from here is the alkenes have always has a -2 than the alkane groups. So let's say that if you have a carbon atoms with 4, it's going to be C4H, 2 times 4 is going to be C4H8. And this time the name would be, instead of butane, it's going to be butene. Okay, if you have 7, it's going to be C7H14, and it's going to be 7 is hept, which is going to be heptene. So I believe we need to remember some of the Greek prefixes in order to name organic compounds. Like 5 is like paint, 6 is hex, 7 is hept, okay, 8 is oct, 9 is dec, and I'm sorry, 9 is non, sorry, 10 is dec, 10 would be dec, okay. So if you have 10, C10, H20, it's going to be decane, D-E-C-E-N-E, okay. So the last group I would like to discuss for our class is going to be the alcohol group. The alcohol group. How do I identify the alcohol groups? Now the alcohol groups have a suffix or a functional group. I'm sorry, functional group, OH. Please don't get confused with the OH in inorganic compound. In organic compound, OH refers for alkaline solution. Whereas for organic compounds, OH for organic compounds, this is for inorganic. Okay, for OH for organic is the alcohol group. So like alkane and alkene, they have a general formula. So I would like to start by writing general formula for you. You have CnH2n plus 1 OH. So say for example you have pentane, right? Pentane is an alkane family, and pentane has to have C5H12, right? And if I would like to have pentanol would be C5H 2 times 5, which is 10, plus 1 OH, which is going to be C5H11 OH. It's always one less hydrogen than pentane. Okay, so this time it's going to be pentanol. If I need octanol or hexanol, let's say octanol. Okay, octanol comes from octane. So octane would be C8H 2 times 8 plus 2. That's octane. C8 H18, I believe. This is octane, right? So if I need to get octanol, I would have one less hydrogen, C8, H17, or H. That's called octanol. So in summary, we discussed about the different families of the organic compounds, which are alkane, alkene, and alkyne. We also discussed about how to name inorganic compounds. In inorganic compounds, you have two options. You have a monoatomic anion and a polyatomic anions. In a monoatomic anions, you use a suffix IDE. In a polyatomic anions, you use a suffix ATE or ITE. ITE is always one less oxygen than the ATE groups. The ATEs are the standard one, which you need to somehow memorize or study. But you don't need to memorize the ITE group or the hypo ITE or the per, because they always comes with either you are adding one oxygen to say per, or you are taking away one oxygen to say hypo. So this would happen for inorganic compounds, especially when you are dealing with a polyatomic ion. For a monoatomic ion, you just use a suffix IDE. So if you have sulfur, if you need S-2, that's going to be sulfide. The same goes for oxygen oxide, for bromine bromide. So I'm going to wrap up this video here. I hope you like this video. I really appreciate for any comments that you have. Please write your comments in the comment section of the video. Anything that needs to be improved. I really appreciate all your comments, and if you like, please share to your friends who will be interested to listen to this video. Thank you, and I'll see you, or I'll meet you on another chemistry presentation. Have a nice one, everybody.